Alright, Neets Module 7, Chapter 4, Part 2. Alright, the LC choke input filter. The LC induction capacitor choke input filter is used primarily with the power source supply for where voltage regulation is important, where output current is relatively high, subject to varying load condition. The filter is used in high-hour applications such as found with the radio communication transmitters. Notice in Figure 419, the filter consists of the input inductor, the filter L1, the filter choke for the output filter capacitor C1. The input inductor L1 is played for the input filter. The in-series is in a series with output for the rectifier circle. The direction of the inductor is to oppose any change of the current flow. The inductor tends to keep the constant current flowing through the lead through the complete cycle with applied voltage. As the result of the output voltage never reaches the peak value with applied voltage. Instead, the output voltage approximately the average value of the rectified input filter shown in this figure. The reactance for the inductor and reduce the amplitude of the ripple voltage with reducing DC output voltage by an appreciable amount. The DC resistance for the inductor is just a few ohms. Should the transformer 1 winding T1, rectifier diode 1 and 2, input indicator L1, capacitor C1, and resistant load resistant. Shunt capacitor charge the discharge of the ripple frequency rate with the amplitude of the ripple voltage relatively small because of the inductor tends to keep the constant current flow with the rectifier circuit loaded. In addition, with the resistance of the shunt capacitor represents the low impedance of the ripple condition existing with the output field for the shunt ripples for the component around the load. Capacitor attempts to hold the output voltage relatively constant, the average value of the voltage. The value of the filter capacitor C1 must be relatively large, representing the low opposition of the capacitive and reactance to the pulsating current with the store of substantial charge. The rate of charge for the capacitor is limited to the low impedance of the source of the transformer, the small resistance of the diode, and by the counter EMF developed by the coil. Therefore, the RC charge for the time, the constant with the shunt short compared to the discharge time, the comparison of the resistor capacitor charge discharge path of the illustrated in views A and B with the figure 420. Consequently, the pulsating voltage of the first applied with the LC choke input filter, the inductor produces the counter EMF force above the constantly input of the voltage of the net result of the effectively prevents the rapid charging of the filter capacitor. Instead of reaching the peak of the value of the input voltage of the capacitor, only charge the average value of the input voltage. Input value reaches peak the degree for the position with the capacitor 1 attempt to discharge through the load resistance of the capacitor 1 will appropriately partially discharge the associated in view B of the figure because of the relatively large load and long discharge time and the large value of the full capacitor, better filtering action. However, because the physical side of the practical elimination of the maximum value of the capacitor. Show the LC, the inductor capacitor choke input filter, transformer 1 winding center tap grounded, diode 1 and 2 on the same path, induction current L1, capacitor C1, and resistor load discharge. Shows the solid stated capacitor. Never mind. T1 transfer winding, center tap D1, D2, induction coil, load resistance, capacitor L1, discharge path. The inductor, also referred to the filter choke with the coil, serves to maintain with the current flow with the filter output with the load resistance nearly constant level during the charge of the discharge period with the filter capacitor. Inductor with the capacitor 1, forming the voltage divider with the component ripple of the applied only input voltage shown in views A and B of the figure 421. As far as the ripple component concerned, with the inductor offers 5-pin impedance, capacitor offers the low impedance view B. But as a result, the ripple component appears across the load resistance greatly intentionated reduce the induced inductance of the filter choke opposed change with the value of the current flow through it. Therefore, the average value of the voltage produced for the capacitor contains a much smaller value of the ripple current ripple component. The value of the ripple produced across the choke. Alright, LC shows your induction choke, inductor capacitor choke input filter, induction capacitor, equivalent circuit, capacitor resistant load, induction high impedance, low impedance, AC component. Now look at 422 with the illustrate with the complete cycle of the operation full wave rectifier circuit that used to supply with the input voltage of the filter rectifier voltage developed the current of the capacitor C1 the voltage at the output of the filter alternating component of the input voltage reduce the amplitude filter section each time of the anoid of the diode give the power with the respect of the cathode of the diode conduct with the capacitor 1 charge Conduction occurred for the two different cycles of the full wave rectifier with a 60 Hz cycle of supply with a reduced 120 Hz ripple voltage. Although the diode alternates, one conducts while the other is non-conducting. The filter input voltage is not steady. The amount of the voltage conducting diode increases the amount of positive half cycle with the capacitor 1 charge with the charge with the having limited by impedance of the secondary transformer winding the diode forward cathode and anode resistant. The counter-EM electromagnetic force will develop in the choke during the non-conductive interval within the anode voltage drop of the capacitor charge and voltage of the capacitor 1 discharge through the load resistor of the component of the discharge path along this constant. Thus, the capacitor 1 discharges more slowly than it charges. 422 shows filter action with the induction capacitor choke input transformer 1 winding sim wave AC diode 1 2 the DC inductor capacitor 1 and resistor load 1. The choke and L, the induction one, we use the large volume from 1 to 20 henries. The other large inductive with the 120 hertz of the ripple with the component with the reduced rectifier. Therefore, the effect of the inductor 1 has the charging of the capacitor 1 must be conserved. The inductor 1 is connected to the series of the parallel branch with the capacitor 1 and load resistance. Division of the ripple AC voltage output DC voltage occur with the greater impedance of the choke, less ripple voltage across the capacitor, and the output of the DC output voltage is fixed mainly on the DC resistance of the choke. Now that you read the LC choke input filter functions, it was discussed actually with the component value that was applied. With the simplicity of the input frequency primary of the transformer was 117 volts at 60 hertz. The both half-wave, full-wave rectifier will be used to provide input with the filter. Starting half-wave configuration shown in Figure 423, the basic parameters are 170 volts AC, root mean squared applied to the transformer, 1 winding primary, 160 volt AC peak available to secondary, 117 volts times 1.414. or 165 volts should recall the ripple frequency half-wave rectifier 60 hertz. Therefore, the capacitive reactance is C1. Capacitive reactance is 1 over 2 times pi times the frequency times the capacitation, or 265 ohms. 423 half-wave rectifier induction choke input filter, 117 root mean squared into the transformer winding diode 1 induction coil 10 henries, capacitor 10 microfarads, resistant load 10 kiloohms, load inductance reactance is 2 times pi times frequency times the load. 2 times 3.14 times 60 times 10, 3.8 kiloohms. The above calculations show the induction offers the relatively high position of 3.8 kiloohms to ripple comparison opposition from referred in capacitor 1 265 ohms. The most ripple will be dropped over the induction cross of the capacitor. In addition, with impedance of the capacitor 265, the relatively low respect with the resistant load of 10 kiloohms. Therefore, the more ripple the current flow for the C1 than load. Other form C1 shown for the most over the AC components around a load. Let's go a step further. Redraw the filter circuit to show that the voltage divider again. Action refer to view A with the figure 424. Remember that 165 volts per peak of the 60 hertz provide with the rectifier consistent in both AC and DC components. The further first discussion we will be about the AC components. The figure of the UC with the capacitor 1 offers the least opposition with the 265 ohms with the AC component. Therefore, the greater amount of the AC will flow for the capacitor heavy line with the View B indicated the current flow through the capacitor bypassing shown as most of the AC around the load. For figure 422, 424 show the AC component of the induction capacitor choke input filter induction the inductance resistance 3.8 induction coil capacitive the capacitive reactance 265 ohms 10 kiloohms on the resistant load, equivalent 265 ohms on capacitor 1, 10 kiloohms, 3.8 kiloohms resistor. By combining the capacitation reactance with capacitor 1 with the resistant load resistance and the equivalent circuit of the VUB have the equivalent impedance of 265 ohms. Alright, so the total resistance is equal to resistor 1 times resistor 2 plus resistor 1 times resistor 2 over resistor 1 plus resistor 2. You have the voltage divider of figure 425. You should be covered the impedance ratio of the large amount of the ripple voltage drop off the inductor. One substantially smaller amount of drop of the capacitor and load resistance. Further increase the ripple voltage of the induction L1 by increasing the induction Capacitive inductance equal to 2 times pi times the frequency times the load. Large ripple voltage 3.8 kiloohms. Impedance 3.8 kiloohms. Capacitor 265 ohms. Load resistance. Small ripple voltage. Impedance 258 ohms. Now let's just discover the DC component supply voltage. Remember, the capacitor offers infinite impedance to flow with the direct current with the DC component. Therefore, most of the flow load resistant and induction coil L1 farther with the DC and concerned with the capacitor does not exist. The coil and lead load therefore series with each other. The DC resistant filter choke is very small, 50 ohms average. Consequently, most of the DC component is developed across the load. Very small amount of the DC voltage is dropped across the coil, as shown in Figure 426. 426 is the DC component and the induction choke input, induction capacity choke input filter capacitor, infinity road resisting 10 kiloohms, the induction 50 nominal. As you have noticed, both the AC and DC components flow through the induction L1 because of the frequency sensitivity coil provides the larger resistance to AC, smallest resistance to DC. In other words, the coil opposed to any change of the current, the property made for the coil with a high desirable filter component. Note the filter action of the LC choke input filter is provided improved with the filter U the conjunction full wave rectifier shown Figure 427. The D with the resistance of the capacity reactance over the filter capacitor increase load capacitation inductance capacitance and load resistance capacity resistance. Remember the frequency full half wave rectifier twice half wave rectifier 60 hertz ripple 120 hertz. Capacitive reactance capacity 1 load resistance for the L1 are calculated as follows. Capacitive reactance is equal to 1 over 2 pi frequency times capacitation 132 ohms. Inductance reactance is equal to 2 times pi times the frequency times load 7.5. 427 full wave rectifier with an LC input filter, transformer 1 T winding center tapped, grounded D1 and D2 diode, and then the induction 10 coil L1 10 henries, capacitor C1 10 microfarads, or resistant load 10 kiloohms. With in capacitive reactant filter capacitor provides less opposition with the flow of the AC. Greater the AC flow through the capacitor, lower the flow with the load, with conversely larger with the inductance reactant of the choke with the greatly ample with the ripple with develop the cross of the choke. Consequently, less ripple to develop the cross of the load, better fitting is obtained. Failure analysis of the LC choke input filter. The filter capacitors are subject to open circuit, short circuit, excessive leakage. The series inductors are subject to open windings and occasional short turns and short circuits to the core. The filter capacitor with the LC choke input for the filter is not subject to the extreme voltage serves because of the protection offered in the inductor. However, each of the capacitor can be become openly and leak short turns in choke may reduce the value of the inductance below the critical value. This will result in the excessive peak rectifier current amplify accompanied by the abnormal high output voltage except the ripple amplitude poor voltage regulation. When choke winding is open, the choke winding of the short of the core will result in the no output condition with the choke winding of the short of the core, more overheating rectifier elements and blown fuses. When supplying the voltage, remove the input filter circuit with the ON terminal with the capacitor is disconnected from the circuit with the capacitor should be checked with the capacitation analyzer to determine the capacity leak of the leakage resistant. The capacitor electrolytic must use the correct polarity at all times. A decrease in capacitance loss of the capacitor can decrease the efficiency of the filter and can produce excessive ripple amplitude. Alright, your resistor capacitor filters. Resistor capacitor input filters, limited action, application load current, and simpler with the type of the filter with the power supply with the load current constant voltage regulation not necessary. For example, the resistor capacitor filters use the high voltage power with the supply with the cathode ray tubes and decoupling networks and multi-stage amplifiers. Figure 428 shows the resistor capacitor input filters associated waveform, half wave, full wave rectifier used to provide input. The waveform shown in view A, figure represents the unfiltered output with a typical rectifier circle. Note the dashed line in view A to indicate the average value of the output voltage and the halfway for the half wave rectifier. The average output voltage is less than half of approximately 3.18 amplitude. The voltage peak of the average voltage value without output voltage, average voltage full wave rectifier is greater than half of 0.63, but is so most likely less than the peak of the amplitude rectifier output waveform. The no filter circuit connected across the output of the rectifier circuit. The unfiltered waveform has large value with pulsating component as compared with the average DC component. Alright, A shows your unfiltered output voltage rectifier. Shows the input rectifier, capacitor, induction reactor, reactant resistor, R1, capacitor 2, resistor load, inductance, resistor load, output load. Half wave rectifier, 1 cycle, 3.18 peak average. Full wave rectifier, 6.3 average peak. Voltage across the capacitor, 1 average. Voltage ripple, average voltage, ripple, average voltage ripple, voltage average, voltage ripple, voltage average, voltage across the capacitor 1 and 2. Alright, the resistor capacitor filter within figure 428 is for the input filter capacitor C1 series resistor was R1 and the output filter capacitor C2. The filter sometimes referred to the RC pi section filters because of the schematic symbol that represents with the Greek letter pi. Signal capacitor filter suitable with the main non-critical low current applications. However, when the load resistance varies low within the percent of the ripple must be held with the absolute minimum. The capacitor value required with the move must be extremely large. Electrolytic capacitors available in size up to 10,000 microfarads. Greater large size with the quite makes sense with the most practical approaches used with the most sophisticated filter can do some of the job. Low capacitors values such as resistor capacitor filters such as view A and B C. Figure 428 show the output waveforms, half wave, full wave rectifier. Each waveform is shown with the RC filter connected to the car for the output. The following explanation of the filters, how which you that an RC filter type of the design does the much job than the single capacitor filter. Capacitor 1 performs exactly the same function as it is a single capacitor filter. You reduce the percent with the ripple to relatively low value with the voltage across the C1 makes it an average EC value with 100 volts. The ripple voltage at 10 volts peak to peak. The voltage passed through resistor 1 and capacitor 2 network reduces the ripple even further. Capacitor 2 offers the infinite impedance resisting the DC component with the output voltage, thus the DC voltage path load reduces the value of the amount of the voltage drop that causes resistor 1. However, the resistor 1 is generally small compared to load resistance. Therefore, the drop of the DC voltage by resistor 1 is not drawback component value of the design with the resistor 1 much greater than the reactance, the capacitive reactance of the capacitor 2, the ripple frequency. Capacitor 2 offers very low impedance for the AC ripple frequency, thus the AC ripple, since the voltage divider constant is consistent with the ripple resistor 1 and capacitor 2 between the output of the rectifier and ground. Therefore, the most of the ripple voltage that drops off the resistor 1 only achieve the ripple voltage can be seen across capacitor 2 and the low of the extreme voltage. Extreme case of the ripple must be held with the absolute minimum. A second stage of RC filtering can be added. The practice of the second stage rarely required. The RC filter is extremely powerful because the small capacitors can be used with good results. The RC filter has some of the advantages. First, voltage drop of the resistor 1 takes the voltage away from the load. Second, power is wasted with the resistor 1 dissipated from the form unwanted heat. Finally, the load resistance change of the voltage across the load and change will change even though the advantage of the RC filter overshadows the disadvantage in many of these cases. Or your failure analysis of the resistor capacitor filter. The shunt capacitor C1 and C2, the subject of the open circuit, short circuit, except the leaks. The series filter resistor is subject to change the value. Occasional opens with any of the trouble can be easily detected. The input capacitor C1 with the greater pulsating voltage applied to it, the most susceptible voltage across surges. The result input capacitor frequently subject to the voltage breakdown, shortening, remaining shorting. Shunt capacitor filter circuit not subject to the voltage across surges because of the protection offered by the series of filter resistor 1. However, the shunt capacitor can become open and leaky shortage. A shorted capacitor open filter results resistor or results in no output indication. Open filter resistor result abnormally high DC voltage at inputs of the filter, no voltage output with the filter. Leaky capacitor filter resistors having loss of effectiveness. A filter resistor that has been decreased may result excessive ripple amplitude output of supply. Alright, your LC capacitor input filter. The LC impact capacitor input filter is one of the most common used filter. The two types of filter used with the primarily radio receiver small audio amplifier power supplies. Any type of the power supply where the output current is low and load current is relatively constant. Figure 429 shows the LC capacitor input filter with the associated waveforms, both half wave and the full wave rectifier circuit they use to provide input. The waveform shown view A with the figure represented the unfiltered output with the typical rectifier circuit with a note that the average value of the output voltage indicated with the dashed line with the high half wave rectifier less than half the amplitude voltage peak with the average value of the output voltage over the full wave rectifier is greater than half and still more than the peak amplitude of the rectifier output waveform. The no filter connected across the output rectifier circuit with the result unfiltered output voltage. The waveform and its large value pulsating component ripple is compared to the average DC component. Our figure 429 shows the LC filter waveforms. The input capacitor 1, induction 1, current 1, L1, capacitor 2, load resistance, half wave rectifier 1 cycle 3.18 peak to peak average. 6.739 average voltage, full wave rectifier, unfiltered output voltage from rectifier. Voltage ripple and voltage average, voltage ripple, voltage average, voltage across capacitor 1, voltage across capacitor 2, average ripple, full wave rectifier. Capacitor 1 reduces the ripple relatively low level of UB. The inductor L1 and then C2 from the LC filter reduce the ripple, but the further the L1 is larger value of the iron core inductor choke. L1 has a high value with inductance and therefore the high value of the inductance reactions rather than high reactions with the ripple frequency. At the same time, capacitor 2 offers very low ripple reactions through AC ripple. The inductor 1 and capacitor 2 AC voltage divider because of the reactions to the L1 much higher than the C2 must ripple the voltage drop across L1 only slightly trace the ripples across C2 load VUC. Alright, the the L1 and C2 network greatly reduce the AC ripple little effect on DC. You should recall that the inductor has no reactance to DC. The only opposition to the current flow resistant of the wire with the choke, generally the resistant very low DC voltage dropped across the coil is minimum. Thus, the LC filter overcomes the disadvantages of the RC filter. Aside with the voltage divider effect, the inductor improves the filtering any other way. You should recall the inductor resistor change the magnitude of the current flowing through it, and consequently, the inductor passes placed in a series below the inductor maintains steadily current. In this term, that helps the voltage across the load remaining constant with the side of the components in factor. The LC filter provides good filtering action with a wide range current. The capacitor filters best with the load drawn and little current. The capacitor discharges very slowly. Output voltage remains almost constant. On the other hand, inductor filters best with the hot current is highest. The complementary nature of these two components ensure the good filtering will occur with a wide range of currents. Alright, your LC filter has two advantages. First, more expensive of the RC filter because an iron choke will cost more than a resistor. The second disadvantage of the side of the iron choke is bulky and heavy. In fact, it may render an LC filter suitable for the many applications. Alright, your failure analysis of the LC capacitor input filter. Shunt capacitors are subject to open circuit, short circuit successful leakage. Series indicators are subject to open windings and associated short turns, short circuits to core. Input capacitor C1, great pulsing voltage applied to the most successful voltage, greatly highly average voltage applied. Result of the input capacitor frequently subject to voltage breakdown. Shorting output capacitor is not susceptible to voltage surges because of the series protection off of the series inductor L1. The capacitor can become open leaking or shortage. Shorted capacitor open filter choke winding with a shorted core with the result of no input output indication of the shorted capacitor. Depending on the magnitude of the short may cause the shorted rectifier transformer filter choke may result with a blown fuse of the primary of the transformer and output choke filter choke result in abnormal high DC voltage input of the filter, no voltage output of the A filter, leaky or open capacitor filter circuits, result with the low DC output voltage. This condition generally accompanied with excessive ripple amplitude, shorted turns in the winding as the first choke filter choke reduce the effective induction choke and choke decrease the filter efficiency. As a result, the ripple amplitude increases. Alright, your voltage regulation. Ideally, output with the most of the power supply should be constant voltage. Unfortunately, this is difficult to achieve. The two factors can cause the output voltage to change. The first AC line voltage is not constant, so-called 115 volts AC can vary from 105 volts AC to 125 volts AC. This means the peak AC voltage to which rectifier can vary is 148 to 177 volts. AC line voltage can be responsible for 20% of the DC output, but the second factor can change with the DC output voltage. Change the load resistant and complex electronic equipment. The load can be changed and the circuit of the switch and in and out of the television receiver. The load of the particular power supply may depend on the brightness of the screen, the control settings, even the channel selected. The variation of the load resistance time of the chain with applied with the DC voltage because of the power supply has fixed internal resistant load resistance decrease with an internal resistant power supply drops more voltage with the decrease of the voltage across the load. Many circuits are designed to operate with a particular supply voltage, with the supply voltage chain with the operation of the circuit may adversely affect with consequently some types of equipment must have power supplies with that produce the output voltage regardless of the change in load resistance. Changing the AC line voltage, the constant output voltage have been achieved with the adding in the circuit called voltage regulator output filter. There are many different types of regulators today, and to discover them, all of them that would be beyond the scope of the chapter. Alright, load regulation commonly given the figure of the merit power supply percent of the regulation. The figure of the merit with an indication of how much of the output voltage change with the range of the load, but the resistant value of the percent regulation aids of the determination type of the load regulation. The need of the percent regulation is determined by the equation. Percent of the regulation is equal to the number of the number of load full and the full load over the full load times 100. Equation comparison: change the output of the two load extreme of the voltage of the preceding full loading. For example, the power supply reduced to 12 volts. The load is currently 0. The output voltage is 10 volts. The full load current flow, the percent of the regulation, percent of the voltage of the number of the load time minus the number of the full load over the voltage of the full load times 100. Would you get 20%? Ideally, output voltage cannot change with the full range of operation. The 12-volt power supply should be 12 volts, no load, full load, no load and full load at all positions between, and K for the percent of the regulation. Percentage regulation: voltage of the no load minus the voltage of the full load over the voltage of the full load 1 times 100, you get 0%. Or the 0% load regulation is an ideal situation, meaning the output voltage is constant under all conditions. While you should strive for 0% load regulation, particular struggle you must settle for something less ideal. Even so, by using the voltage regulator, you can hold the percent of the regulator with a very low value. Regulators: you should know the output power supply vary with the change of the input voltage circuit with the load current requirements. Base cover the many of electronic equipment requiring output voltage current that must remain with the constant some form of the regulation necessary circuit to maintain power supply voltage current output with the specified limits. Tolerances are called regulators. They are designed to DC and DC voltage DC current regulators depending on the specific application. Voltage regulator certain circuit addition with the basic power supply circuit that might be added to the rectifier filter section. The purpose of the voltage regulator to provide output voltage with little or no variation. Regulator circuit sends the change of the output voltage compensated by the change. Regulators maintain voltage plus or minus 0.1% are quite common. So the input rectifier filter overhead voltage regulator DC overhead voltage output. Series shunt voltage regulator: the two basic types of voltage regulator. The basic voltage regulator classified as series or shunt, depending on the location, position, regulating element, the relation to the circuit load resistance. Figure 431 shows the UAVUB illustrate the two basic types of voltage regulators supplying actual practice circuitry. Regulating device may be quite complex, broken. Have they been fixed with a little difference between the series and shunt? You got your resistor shunt and variable resistor shorted. And your variable resistor shorted resistor shunt series regulation. Schematic drawing view A is that of the type of the shunt type of the regulator is called the shunt type of the regulator because of the regulating device connected with the parallel load resistant. The schematic diagram view B of the series regulator called the series regulator because of the regulating device connected with the series of the load resistant. Figure 432 illustrates the principal series of the voltage regulation. The start of the figure notice for the regulation series of the load resistance and the fixed resistor interior of the load resistance. So you have the regulator voltage and the DC output the resistor load resistant load on and regulated DC input. You already know the voltage drop of the cost of fixed resistor remains constant unless the current flowing through the very increase the decrease of the shunt regulator. Also shown figure 433. Output of the voltage regulation is determined with the current parallel resistant regulating device. Load resistance and series resistance. For now, assuming the circuit is operating with a normal condition and input with 120 volts DC, the desired regulated output of the 100 volts for the 100 volt output with the maintaining 20 volts must be dropped across series resistor. If you assume the value of the series resistor is 2 ohms, you must have the 10 amperes for the current of the regulating device and the load resistance. Remember that voltage equals amp over ohm. The value of the resistance of the voltage resistance and a load resistance is equal to 5 amperes. Current will flow through each of the voltage resistant amperes, the load resistance, and the regulated voltage regulation.